Hey guys, so we're talking about functions now, and for this video it's only linear functions, and by linear functions we're actually talking about those straight lines on your Cartesian plane, right? Cool stuff. And the general form or the structure of a linear function, what it looks like, it's y equals to mx plus c, right? So c here we can just say that is just a constant term, right? It's the constant term, and then x is the x value, y is the y value, right? And here, this right here is the gradient of your functions, right? Which talking about the formula, so gradient is equals to changing y over changing x, and that change, oh no, changing x, and that change can be y1 minus y2 divided by x1 minus x2, right? Or it can be y2 minus y1 over x2 minus x1, right? But can never be x or anything like changing x over changing y. This is not gradient, right? We talk about changing, okay, say y2 minus x2. This is not how it's done. Y1 minus x1, this is not how it's done. That's not how you calculate your gradient, né? So your gradient is just changing y over changing x, right? Which is, it could be any of these two, right? Cool stuff. So now also what your gradient tells you, if it's negative, okay, so let's have our Cartesian plane, right? So if your gradient is negative, you know that your graph is something like this, right? So what are we saying here? I'm gonna do this. Let me use a different color. Right, let me do this. Yeah, I'm boiling something there. So what you realize there is that for, if we increase x values, y values are going to decrease, né? Yeah, we increase x values. Yeah, okay. Alright, cool. So you realize that here, as x values, remember this is your x axis, this is your y axis, right? So as what's happening if we move from the left to the right, x values they increase, right? So let's see the relationship, what happens when x increases to the y values now. So we are here, and here is the y value. Once we increase x, the y value decrease. We further increase x, the y value decrease, right? We further increase x, y value decrease, and we further increase x value, y value decrease. So you are saying that the relationship here is that if we have a negative gradient now, so if m is smaller than 0, right, that's a negative gradient. You have what? You have your, as x values increases, y value decreases. As y value decreases, x value increases, right? That's the relationship. But then if you then have a positive gradient, né? For a positive gradient you have something like this, right? And here you will see that we increase the y value increases. We increase the x value, the y value increases. Increase the x values, y value increases. We decrease the x value, right, the y value also decreases. So yeah, so here we can say there's an inverse relationship, but then here where m is greater than 0, we have a proportional, yeah, or here it's an inversely proportional relationship, yes. And then here for positive gradient we have proportional, not inversely proportional. yeah. Alright, cool. So now I'm gonna give you one of the best strategies, bro. Whenever you have a function, they gave you a function, they like, man, look, find me the value, or find me the, what is this, find me the function define the function, right? Or find a general formula for the function, right? So you only need like 2 points. Now if you have this point and this point, bro, I'm telling you, you have all that you have. You have all that you have. Wow. uh okay, if you have 2 points, now any 2 points, I am telling you, you have all that you need, right? Because these 2 points, number one, they will help you calculate your gradient. Now after you have your gradient, say your gradient equals to m equals to, so this one, of course, it's increasing, so m is equals to 2. So with m equals to 2, right, you will just say y equals to mx plus, oh, you know your m, it's 2x plus c, right? And then what you do is you go to one of your coordinates, right? You substitute x and y. After substituting x and y, you solve. Eventually you're gonna get the value of c, and from there, man, you are done. You are done. And another thing is, like, you see, soon as you have a straight line and one of your points, one of your coordinates is on the y-axis, you are done, bro. Because also c, this c, right, we can say it's y intercept, right? C is y-intercept, because look, bro, y equals to mx plus c, ne? You find y-intercept, you know x is equals to 0, so you have m into 0 plus c, and then y will be c, right? So if you happen to have a point on your y-axis, bro, like you won't even stress a lot, because you will just say for example, this is minus 2, right? You will just say y equals to mx minus 2, and look, right, from here, it's your decision, it's your decision. You can find your gradient the traditional way of using changing y over changing x, but alternatively, you can also do what? You can also look for any other point except this one. You don't want to use this one, you look for any other point except your y values, coordinates on your y-axis, and you take that point. Say maybe you found a point here, right? 2 and 3, right? You take that point, you're going to substitute it for y and x, and from there, bro, you are left with m. You find m, and then you are done, right? So in just an example here, you build 3 is equals to m multiplied by 2, of course, minus 2, right? You go that side, this become plus, so you have 5 this side equals to 2m, you see, and then you divide by 2 both sides, then you have 5 equals to 5 over 2 equals to x. You feel me? 5 over 2 equals to x. That's it, boy. It's that simple, ne? Let's go do a couple of problems. Oh, okay. Before that, there is something. Yeah, it was good that I noted it down, otherwise I would have forgotten. I would have forgotten, and then all of a sudden I see a question asking about the domain and range. So we have also this thing called domain, right? We have this thing called range, right? We'll also talk about the intercepts, right? Plotting the graph is something we're going to do. Yeah, cool. So for the domain, we are actually saying which x values, is our function defined on, right? Or like we can also say on our function, which x values are the valid x values for our function, right? Because there are certain times you will see with other graphs, there are x values that can never be part of the function, and there are y values that can never be part of the function, right? You will see that, we'll get to it. But here, unfortunately or fortunately enough, here there's no limit, right? Any linear function, when it's like this, it's gonna go down like this, it's gonna go up like this, so every value is defined here. So a straight line, you don't have to stress. When you have a straight line function and you get a question that say what's the domain, what's the range, you don't have to think about it, because it's always and will always be from negative infinity to positive infinity, right? and the same as range as well, from negative infinity to positive infinity. So this is something you don't have to think about it, you don't have to stress yourself about it. It's that simple. And I will talk much more about domain and range when we get to other functions, because they allow us to explore this thing of domains and ranges much properly. Because here for linear, any linear, it's always like that. You see a domain for linear function, negative infinity, right? You can just say x is an element of, we have yeah, bro. Bro, like negative infinity, positive infinity, just like that. You don't have to think about it. And then as for intercept, we have two of them, right? We have two of them. Basically, you have your y-intercept and you have your x-intercept. Yeah, you have your x-intercept, you have your y-intercept, and with these two intercepts, with these two intercepts, for y-intercept, you know that x equals to 0. For x-intercept, you know that y equals to 0. So in short, what are we doing? When you are asked to find y-intercept, you go into your function, and where you see x, you substitute 0, right? And when you are asked to find your x-intercept, you go into your function, where you see y, you substitute 0. For x-intercept, y is 0. For y-intercept, x is 0. You see it? So we will do a couple of examples, and they will give us a clear picture of that. So here we have this point. Of course, we have our function f, and this is f of x, and our coordinates here, it's 2 and 2. Here it's -1 or 0 and -1, right? You already see that the nicest thing. I'm glad actually this was the first one, because here, before you even think about it, you say y equals to mx plus c, and then from there you substitute mx -1. Why -1? Because you know that c is the y-intercept, the y value intercept. C is the value for the y-intercept. Yes. So we have -1 here, then that is c. From now you can just go 2 equals to m multiplied by 2 minus 1. You go that side, 2 plus 1 equals to 2m. 3 equals to 2m, right? And therefore m equals to 3 over 2. Therefore y equals to 3 over 2 x minus 1. Do you see, friend? Yeah, and it works. You substitute 2 here, the 2 will cancel. You have 3 minus 1, that is 2, which gives you 2. So this is the function, this is how we find it. And for this, I will remove these. So for this question, maybe they would ask you, I'm not gonna do the domain and ranges, because the values are always from negative infinity to positive infinity. But I could say I have, this is my y-intercept here. I could say, what's my x-intercept? So like x-intercept y equals to 0. So you go to your function, like 0 equals to 3 over 2x minus 1, right? And then you have 1 equals to 3 over 2x, and then you multiply by 2 over 3, right? So these, they're gonna cancel, and then this side you're gonna have 2, here you're gonna have 2 over 3. So here, this point right here, that is your x-intercept, right? And that is exactly where y is equals to 0, right? And this point, if I call it a, I will say my a is 2 over 3 and 0, right? Just like that, friends, just like that. Let's go to the next one. Mara, why did I do this? I don't know. Okay, let me just do something. Maybe I was not thinking when there's just a higher chance that I was not thinking. Let's say your function is something like this, Cool. So from this function, you see we are moving here, right? In fact, let me make it more interesting. Let me make it more interesting. Right. So I'll make it more interesting and say, yeah, then here we have a point here which is that's minus, that's, oh, that is 3 minus 2, and then here I have minus 2 5, right? That's my coordinate over there. So now I will do it the traditional way. Say m is equals to changing x. Oh no, changing y over changing x. Oh no, changing y, I'm like 3. Changing y is y1 minus y2, x1 minus x2. Then I have 3 minus, hey, no, minus 2 minus 5, and then 3 minus 2 minus 7 5, right? Therefore that is your gradient, minus 7 over 5. And it makes sense because our gradient is what? It's a decreasing. Remember, decreasing, it's always like this, né? So it is a decreasing function. Then therefore you have y equals to minus 7 over 5 x plus c. To find c, we substitute some value. Let's substitute this one, yeah? So you like 5 equals to minus 7 over 5 into minus 2 plus c, right? So you have 5, you have positive 14 over 5 plus c. We go this side. Let me say I have 25 over 5 minus 14 over 5. I do the math. 25 minus 14, 11 c. So therefore I have 11 over 5 as my c. That would then mean that my function is going to be minus 7 over 5 x plus 11. Oh look, 11 over c. What the hell? 11 over 5. Yeah, 11 over 5. And of course, now say they like, okay, chief, can you find us our x-intercept, our y-intercepts here? Because yes, we see them, right? We see them. The reason I'm saying we see them, this is your y-intercept, this is your x-intercept, but we don't know the value. So you take your function, you like y-intercept x equals to 0. So therefore you have y equals to minus 7 over 5 into 0 plus 11 over 5, and therefore the answer is 11 over 5. And then here you know you have 0 and 11 over 5, right? Whatever that would be. And then you go again, you're like, okay, x-intercept y equals to 0, right? So you go, you're like 0 equals to minus 7 over 5 x plus 11 over 5, ne? Let's say we have minus 7x plus 11 over 5 equals to 0. You multiply by 5, you therefore have 0 equals to minus 7x plus 11 minus 11 minus 7x, and therefore your answer is going to be, x is going to be, we divide by 7, in fact minus 7, so you have 11 over 7. So here you know you have 11 over 7 and 0. You see how it's done? Nice one. And okay, I have a couple of these. Okay, I just want 2 examples. This one looks interesting, so we'll do this one and this one. So basically here we're going to graph these things, we're going to plot them, ne? Away. Cool. So for this one, yeah, they give you the function, here it is, and they're like, can you please plot this one for us? Yeah, this is how you can easily do it. Cartesian plane, the most important one, yeah. And then so how you can do this thing, one of the easiest and the best way to do it is by using purely x-intercept and y-intercept. I'm telling you, bro. So you like y-int x equals to 0, therefore y equals to 2 0 plus 1, therefore 1 equals to y. Then you go like x int y equals to 0, and then you're like, okay, so 0 equals to 2x plus 1 minus 1, 2x, therefore x equals to minus 1. So yeah, this point here it's 0 and 1, and this one is minus 1 and 0. So you go and plot them, minus 1 and 0 for x. Here we are. And then maybe that's too far. Here we are. And then here is 1. Right? Then you just draw a straight line going through those 2 points. Let's see. Yeah. Okay. Let's say this is where negative 1 is. So you have 0 and 1. You have minus 1. In fact, oh my word, divided by 2, bro. Divided by 2. Oh my word. My word. Yeah, just a silly mistake. But yeah, this is your function here. And then maybe you can just put in another value and say f of 3, right? It's going to be 2 into 3 plus 1, so that is 6 plus 1, that's 7. So you're like, here you have 3 and 7, right? And then you are done, right? You are done. And then here we go again with the same thing. In fact, let's use this one. So for this one, of course, you like x-intercept y equals to 0. Right, so you have 0 equals 3 minus 3x. You have 3x equals to 3, therefore x equals to 1, right? And therefore you have 1 and 0. Y-intercept x gives you 0, so therefore what do you have? You have y equals to 3 0, and therefore y equals to 3, therefore you have 0 and 3, right? So you go here, what do you have? 0 and 3, 1 2 3, this is 0 and 3, and then 1, this is 1. Then you just draw a straight line going through these 2 points. Chief. Let me see. Can't I move you, Chief, and rotate you maybe? But it's fine. I can just say inaccurately, so I can just say this is my point. Yeah, I can just say this is my point. So then I have 0 and 3. I have 1 and 0, right? And I can substitute other points, say say what? Say maybe I substitute 2. So I have 3 minus 3 into 2, that's 3 minus 6, which is minus 3. So then here I have 2 and minus 3, right? Yeah, So this is how you plot it, and other questions, they're quite simple. Wait until we do more examples or more questions on linear functions. I'll see you in the next video, fellas.